Hello dear students, we have already discussed about the reduction reaction. If you recall, when I begin with the reduction reaction, we were discussing about the classification of certain organic compounds, how one of the compound will get reduced to another one, like alcohol from ketone, carboxylic acid will get converted to ketone, like that. So, what is oxidation in organic chemistry? So, in general, in the broad definition of oxidation and reduction respectively, refer to the loss of gain of electron or increase in the oxidation number, that is called oxidation, and decrease in the oxidation number is called reduction. So, I have given more writings in order to make you understand more. So I would have given only important points, but I have given the definition so that you will understand better. In organic chemistry, the gain of oxygen or loss of hydrogen is often referred to as oxidation. In practice, a series of functional groups have been qualitatively identified in the order of increasing oxidation state. Then, oxidation state is referred to as the conversion of one functional group higher in the sequence to another lower in the list. So, the list is this. So, conversion within the group having the same functional group are neither oxidation nor reduction. So, you could see here, if you move from left hand side to right hand side, that's nothing but the oxidation. So here, as you see in the picture, if you move from left hand side to right hand side, this is nothing but the oxidation, and this side it is reduction. So here you could see that the alcohol, alkyl halide, amine, etc., and alcohol could get converted to aldehyde or ketone. It could get converted to amide, and the RH means alkane, ANE. This is alkene and this is alkyne. They can get converted to alcohol, and this is the form of carboxylic acid, carbon dioxide. And here all this, if you move from this side to this side, it's nothing but the oxidation. As I have told in the one of the previous class, this to this side it is reduction reaction. So mainly when you focus in this particular chapter, oxidation, main focus is on the conversion of alcohols to ketone. So primary alcohols will get converted to aldehyde, secondary alcohol will get converted to ketone. And here, if you take the primary alcohol, it will get oxidized to give aldehyde. The reaction mostly may not stop over there, and it will give carboxylic acid. Whereas in case of secondary alcohol, the reaction is not that much strong, so that it will give ketone, and the reaction may stop over there instead of giving carboxylic acid. So you might have heard of the general oxidizing agent, and the most commonly used methods of oxidizing alcohols are based around the metals in high oxidation state. Often it could be chromium 6 or it could be manganese 7, and you could see that mechanistically they are quite similar. They both rely on the formation of a bond between hydroxyl group and the metal. And another class of oxidation, those that use their halogens, sulfur or nitrogen in high oxidation state. So let's go through, like if you take, see here you could see alkene. Alkenes are getting oxidized to alcohol or the carboxylic acid, like that. So here there are few reagents which is really chemoselective. They only oxidize CC double bonds. They are like parasites. It could be written as RCO3H. They are like osmium tetroxide. It could be ozone. You must have heard of ozonolysis. Whereas there are few reagents which will convert the alcohols to aldehydes or ketones. They are the best reagents are chromium in +6 oxidation state, manganese in +7 oxidation state, and there are few compounds which are in high oxidation state of halogen, nitrogen and sulfur compounds. So this is what some little knowledge, like for oxidation of alcohol, even we may use Jones reagent, PCC, pyridinium chlorochromate, and the pyridinium chlorochromate will not make the alcohol to get to carboxylic acid. It will stop somewhere on the aldehyde. That's what the important. So there is a reagent, its name is PCC. That's what pyridinium chlorochromate, pyridinium ion and chlorochromate. There is another one, it is called PDC, pyridinium dichromate. So all these reagents are used for the conversion of alcohols to aldehyde. So we are discussing few important oxidizing agents in this chapter. So let's get into that. So this table must be there in your mind. You keenly observe, because whatever comes in the same line. So you could see that RH if you take, it is normal alkane, the oxidation state of carbon is having a particular value. If you take alkene, so it has a particular oxidation number value. So you analyze this slide. This is very important for better understanding of the concepts of the oxidations in organic chemistry. So the very first one we are going to discuss in this chapter is open air oxidation. Has very wide importance as far as the alkaloid chemistry or the natural products are concerned. So the open air oxidation, it is the oxidation of primary and secondary alcohol with ketone in the presence of a metal alkoxide to corresponding aldehyde or ketone is known as open air oxidation. So this is how it could be represented. So you could see that there is a secondary alcohol on left hand side. You have taken aldehyde, or it's an acetone actually, and you get the secondary alcohol will get converted to a ketone along with the formation of an alcohol. The excess of ketone will get reduced to alcohol. So acetone acts as a hydrogen acceptor and it is transformed into 2-propanol. That's what you could see on right hand side. The use of inert solvent such as benzene, toluene or dioxane minimizes the side products and also helps to rise the reaction temperature. And the very important point about the open air oxidation is the reaction is completely reversible and can be driven to completion according to Le Chatelier principle by addition of the excess of ketone. So you would have seen, you could see that in the previous slide, ketone is written in the place of the reactants. So if you increase the amount of reactants, the formation of the product will become more fast. So this is how the mechanism of the open air oxidation could be represented. So you could see that aluminum isopropoxide is taken as the reagent along with acetone for the oxidation of a secondary alcohol. So you get this product. It is an ester actually of aluminum, and you could see that the arrow mark which is kept over here, it clearly indicate or gives a stress on the point that this is an equilibrium reaction, is a reversible reaction. So you get this aluminum ester and there will be a 6-membered transition state getting formed, and there will be cleavage for that 6-membered transition state, and finally alcoholysis will happen and you will get a ketone. The reaction is reverse of Meerwin-Pandolf-Weyl reduction, MPV reduction. So the ketone, the acetone serves only to form aluminum alkoxide of the alcohol that is oxidized through the cyclic transition state at the expense of acetone to a ketone and to propanol. So this is about the mechanism. What are the advantages of open air oxidation? So it's a challenging work converting an alcohol to aldehyde or ketone and stopping the reaction over there. So in that case, with chemoselectivity or regioselectivity, what is going to happen is if you use open air oxidizing reagent, you will be getting specific product. Mild reaction conditions, that is one of the very important point. Most functional groups are tolerated if substrate contains basic nitrogen. Then use of alkali metal alkoxide is necessary instead of aluminum isopropoxide. So you have to remove, if there is something related to basic character, then you have to remove the aluminum and go for some alkali metal alkoxides. In order to achieve reasonable reaction rate, stoichiometric amount of aluminum alkoxide to be used, like aluminum isopropoxide, aluminum tertiary butoxide, aluminum phenoxide can be used. The wide range of substrates are oxidized. So it's not the oxidizing agent particular to certain compound. It could be used very widely. Secondary alcohols are oxidized faster than primary alcohols. Due to this, secondary alcohol can be oxidized chemoselectively over primary ones. Over-oxidation to carboxylic acid does not happen. It means the reaction will stop somewhere on the aldehyde or ketone. Oxidation of 1,4 and 1,5 diols yield lactones. Lactone structure you will be remembering. Acetone is the most often used as an oxidizing oxidant. But aromatic and aliphatic aldehydes are suitable as oxidants due to the low reduction potential. So they are easy to get reduced. That means it is little easy to get oxidized. Addition of protic acid dramatically increases the rate of the oxidation. Oxidation can be conducted using heterogeneous catalysis. It has an advantage over homogeneous catalysis as the product can be separated easily from the reaction mixture. So if you talk about the organic reaction, it's not only getting more yield in the reaction. What also important is you could separate the products which is getting formed. The reaction conditions are compatible with acetols, acetates and benzoates. However, formate can be oxidized as free alcohol to give ketone. So the oxidation of equatorial hydroxyl groups are favored compared to the axial hydroxyl group. That's what one of the notable point about the open air oxidation. So here testosterone acetate is produced by open air oxidation. So then these two are good examples for understanding the open air oxidation. What are the synthetic applications? Synthesis of estrone from tetracyclic diol. So you could see that the estrone is prepared, which is there at the bottom. The cholesterol is oxidized to cholestenone with the migration of the double bond in the presence of cyclohexanone, which acts as the hydrogen acceptor. So you could see this reaction. You need to write down all these reactions and check what and all changes happened. So this is another set of reaction. Synthesis of linearly fused triquinine and plus or minus is optical activity is important because it's the stereochemical aspect is very important. So another application is this, the synthesis of progesterone from pregnenolone. Pregnenolone. So this is another example. You will come across these type of reactions when we discuss more about the natural products. Then you have a question. This is in class question number 1. What is the product for this reaction?